Hello. Hello. Uh, can you hear me? Hi guys. Can you hear me?
Yes, sir.
Yeah. Okay. And my video is visible, right?
Yes, sir.
So sorry that there was some technical glitch from my side. That's why we are starting very late. Let me share my screen. I hope you can see my screen.
Yes, sir.
Yeah. Okay. First of all, let me introduce myself. I am Nalin Vilochan Mishra. I am from Department of Electrical Engineering and Computer Science, ISA Bhopal. I am the one of the TAs for the course, A Brief Introduction of Microsensor. This course is taken by Dr. Shantanu Talukda. He is from ISA Bhopal. So this is the week 2 for this course. Uh, in week 1, we have revised some concepts of basic mechanics, and we have solved some numericals also. In this week, we will revise some concepts of electrostatics and electromechanical concepts, and we will try to do some numericals. Okay, so I'll start by first revising you all with the basic mechanics. So, if there are two charts, Q1 and Q2, and they are separated with the distance r, then we can write the electrostatic force as 1 by 4 pi epsilon naught Q1 Q2 by r square. And what about electric field? Electric field we can write as 1 by 4 pi epsilon naught q1 by r square. and work done as minus 1 by 4 pi epsilon q by r. So these are three basic formulas we are going to use for basic questions. One more thing, uh, the energy stored, which can be written as half cv square, where c is the capacitance, v is the voltage applied across the capacitor. Okay. Also, we can write c is equals to uh, sorry charge q is equals to cv, so that c will be q by v. Hence, for if we want to write the electrostatic energy in terms of charge, so it will become like this. So u will be half qv. Also, u can be written as half cv, and v can be written as q by c. So u will be half qv, or u will be half uh, q square by c. So these are the multiple formulas we are going to use for the numerical calculations. Okay. So first question, consider an air gap capacitor made with two fixed parallel plates. At zero bias, the distance between two plates is x naught is equals to 100 micrometer, and area of plate can be written as A, which is given as 400 cross 400 micrometer square. The media between two plates is air, and the biasing voltage between these two plates is V equals to 5 volt. So you need to calculate the value of capacitance and magnitude of force F. So the first case is we need to calculate the value of capacitance and magnitude of force F. So please try. You know the basic formula for capacitance, right? Which is C is equals to epsilon A by D, where A is the area of plate and D is the distance between those plates. So basically, like this. So if there are these two parallel plates, then the area would be like this, and D is the separation between these two plates. So you need to use this formula for calculating the value of capacitance. Anyone got the answer? Okay, so let me solve it. So as I said it, we will use the formula C is equals to epsilon A by D, and area is given as 400 cross 400 micrometer square. So it's like this plate, the length and width of the square plate is given as 400 micrometer and 400 micrometer. So area will be 16 into 10 to the power minus 8 micrometer square. So we will put this value, and D is given, I think distance is given as 100 micrometer. So it will be 10 to the power minus 4, and the value of epsilon is 8.854 into 10 to the power minus 12. So the capacitance will be 1.41 into 10 to the power minus 14 farads. So everyone is getting the same answer? I hope. And how will you calculate the force? So the force can be written as U by D, where U is the energy stored in this capacitor and D is the separation. So it will be, U can be written as half CV square, and the value of D is 100 micrometer. So by putting it, we will get the force 10 to the power minus 9 newtons. Anyone has any doubt till here? Okay. So the next part is we need to calculate what is the capacitance value if half of the area is filled with water. The epsilon for water is given as I think 76 times epsilon of air. Okay, so before solving this, can you guys tell me if this is like this epsilon of air, epsilon of water, or like this? The first arrangement or the second arrangement? Can anyone unmute and tell me how these capacitance are arranged? This is the area. The first one. Okay, Prashant. Why would you think so? So what's its written? What is the capacitance value if half of the area? In the first arrangement, I think area is same for both dielectrics. But in this case, the medium air is sharing half of the area and water is sharing half of the area. So it should be second one or first one? Okay, the second one. Anyone else? The other participants, what do you think? It should be first one or second one? Second one? Everyone on the same page? Second? Yeah. Other guys? Should be final On the second arrangement, yeah, so it will be the second one. So my next question would be, this connection, it's parallel connected or series connected? Series connected. Everyone is saying series. Why it should be in series? Tell me. So we all can understand from this figure, the voltage will be same. And if we write Q equal to CV, so we know that voltage will be same. So what should vary? Charge. So we can write total charge is equals to Q1 plus Q2, right? And Q can be written as C. We can write as C1V plus C2V. As V is same, we can finally write C equivalent C1 plus C2. And we know that capacitance in parallel is basically sum of all capacitances, right? Okay. So what you need to do? You need to calculate the capacitance of water, and you need to calculate the capacitance of air. So I have calculated it. Capacitance of water is coming out 5.42 into 10 to the power minus 13 farad, and capacitance of air is coming out to be 7.08 into 10 to the power minus 15 farad. And C equivalent, we know C air plus C water, and hence it will be the addition of these two. Any doubt till here? Like these are the most common question, like the capacitance calculation is the most like asked question in NPTEL exams. So please, you need to try these questions. If you have any doubt, you can unmute and ask me. uh, Danielu Raju Regu, so what is your doubt? All clear? Okay. So there can be some questions like this. You have the dielectric arrangement like this: K1, K2, K3, and this will be C1, C2, C3. So what you need to do? You need to calculate the equivalent capacitance. Please try. Take the value of area as A, and these are uh, the dielectric K2 and K3 are arranged like they are half. They are sharing the half of the plate's area. Anyone has solved it till now? It's a very simple question. SG Akshay. Sir, you showed two ways of having water as half of the dielectric medium. Why isn't the first case possible? In the last question you have doubt? In this, Akshay, can you please unmute? In the last question, okay. In this one, you are solving. First case possible. Okay, so in this, I am saying half of the area is filled with water. Okay, so here I'm talking about area, not volume. So think like this. So these are the two parallel plates, and area of plate is given as, if assume the length of the capacitor is L and W is the width of the capacitor, then area would be L times W. Okay, if I am saying that half of the area is filled, then area must be half length times width. So either length or width needs to be half. In both the cases, it must be the second one, not the first one. It's clear now? Because like think in this figure, the epsilon, this air medium or the water medium, will be fully filled like this. So it will take the whole area. So this is the only possible way. I hope it's clear now. Okay. What about this? What is the C equivalent value? Here, uh, I think the combination, this K2 and K3 are connected in parallel like this, and this combination of two capacitances with coefficient K2 and K3 are connected in series with capacitance with coefficient K1. So it will be C1, C2, C3. And we know that this equivalent, C equivalent, is basically C2 plus C3, and this is C1 only. So we can redraw it like this, where it will be C1 and it will be C equivalent. The Let me denote it as C equivalent dash. So the final C equivalent will be C1 C equivalent dash by C1 plus C equivalent. Anyone has any doubt till here? Okay. So let us move now to another module. So consider a capacitor with two parallel plates where one plate is anchored and another one is suspended by a mechanical spring like this. So one plate is connected with spring and another plate is basically anchored, like it's fixed. Okay, so if we apply a voltage here, then increasing electric field will move the first plate in the downward direction because of the electrostatic force. So when voltage is applied on one plate and electrostatic force will develop, and it is given as F du by dx, where u is the electrostatic energy, and we know that it is given as half cv square. So du by dx can be written as half dc by dx v. Also, please note that in this capacitance, if this is x direction or the distance x, then capacitance will be a function of distance. And this distance is basically what we call d all the times. So it's a function of distance. So here x is basically d. So we can write it as half cv square by d, or half, uh, in the place of c we can write it as epsilon a by d v square. So it will be epsilon a v square by d square, or force can be written as half cv square by d. Okay, this is also uh, electrical force. Okay, so let us do the next question. Find the value of x directed force of electrical origin, or you need to calculate like fe. What is fe? Fe is this. The most general formula is like this. Fe is basically half dc by dx v square. The system of capacitance is given like this. So there is this capacitance and another capacitance is connected in parallel like this. The separation between the capacitance is given as x. This plate and this plate are basically anchored. So these plates are fixed and cannot move, but there is a force in this direction. So the upper plate is movable. This is also x, and this is g by 2, this distance, and this distance is also g by 2. So for calculating this fe, first you need to calculate the capacitance. So you need to find the equivalent capacitance here. Okay, the the dielectric value for this capacitance is given as, okay, you can assume the same medium. So it will be epsilon naught, and this is also epsilon naught. So please try to solve it. First calculate the equivalent capacitance, then you can easily calculate the force of electric origin or the electrical force. So tell me, this system, how they are connected? It's connected in series or parallel? So there are these two capacitances, C1 and C2. Are these capacitance connected in parallel or series? These are connected in parallel. Okay. And we are saying that because the potential is same in uh, both of these capacitances. Like this voltage will be same here also and here also, and charge will be like this. The total charge will be the addition of these two charges. Okay, so someone tell me what is the value of second capacitance? It should be epsilon naught A by X. Okay, so for that you need the value of A, right? So I should also give you the value of area. Uh, this is length L2, this is length L1, and the width is common. So width of both plates is equals to W. So what will be area? Area will be L2 times W. So C2 is epsilon L2 W by X. And what about C1? C1 will be epsilon naught L1 W by X plus G. So C equivalent can be written as C1 plus C2, as these capacitance are connected in parallel. Okay, so it will be epsilon naught W, we can take it out, L1 by X plus G plus 1 by, sorry, L2 by X. So final value of C equivalent will be epsilon naught omega L1 X plus G plus L2 by X. This is the final value of C equivalent. Okay. Now you need to calculate the electrical force. We know that Fe is given as half dc by dx v square. So you need to differentiate the capacitance with respect to x, and after doing it, the answer will be Fe minus omega naught L1 x plus g whole square plus epsilon naught L2 W 2x square V square. Everyone is getting the same answer? Or is there any doubt? If not, then do this. This is air, and the dielectric permittivity is given as epsilon, and this is some medium which has the dielectric medium like this. Consider this plate as fixed. The voltage applied across these two plates is given as V, and this plate is movable. So find the electric force Fe in terms of charge. So how you are going to do this? First, you need to calculate the C equivalent. So can anyone tell me how this C1 and C2 are connected? Are they connected in series or parallel? So is there the distribution of potential or charge? So the simplest thing to check if the capacitances are connected in series or or parallel, like you need to check, yeah, parallel. So is it correct? These two capacitances are connected in parallel or series? So keep this in mind that if voltage is same, which is experienced by two dielectrics, then it is in parallel. But in this, see, this point, the air is experience, let us assume potential V1, and we know that there must be some drop here. So this point will experience some other voltage V2, which is less than V1. So here the potential is not same. Hence these are connected in series. So we can make like this. This is C gap and this is C dielectric. We know that the equivalent capacitance in series connection is given as C gap multiplied with C dielectric upon C gap plus C dielectric. So please calculate C equivalent and tell me what is the final expression for C equivalent. Okay, do you guys need any other information like the area, length, D? So the area of this plate is given as A, and the separation here is given as X, and separation in this dielectric is given as D. Fine. Now please calculate the C equivalent. The separation here is given as X and the separation here is given as D. The area is same A. So have you guys done the assignment problems for week 2? I hope you guys have uh, done and submitted. No? Why? What's the last date for submitting the assignments? Feb 7th. Okay. Someone is saying 2nd Feb. Today is 3rd, right? Is there any extension of deadline or something? Please tell me the final expression. Okay, let me do it. So first of all, we need to calculate C gap. The formula for capacitance is epsilon A by D. The gap is given as X. C dielectric is epsilon A by d, and epsilon of this dielectric is given as k times epsilon. So let me calculate it. The C equivalent will be 1 by C gap plus 1 by C dielectric. So it will be x by epsilon naught A, and this will be d by k times epsilon naught A. Sorry, this will be k. So everyone is getting the same value of capacitance, C equivalent. You can type in the chat box if you are having some difficulty in solving these equivalent capacitances. No? Okay. Now we need to calculate the force. The force is given as half dc equivalent by dx v square, or you can remove the mod value. If the positive values, like if they are only asking the magnitude, then you can take the mod value, or you can calculate it like this only. Half differentiation of this value with respect to x will give you minus epsilon a by x plus d by k whole square v square. But in question, it is asked you need to find the electrical force in terms of charge. So we know that capacitance is given as epsilon a by d, and q is equals to cv. So in this we will multiply epsilon naught times a and divide it, and this can be written as c. So it will be c square v square by epsilon naught a, and according to this, the force, electrical force, can be written as q square by epsilon naught a, and this is the minus charge. I hope it's clear. So these are the type of capacitances questions that you can get in your exams. I have one very interesting problem for you. I will suggest you to do in your home. It's a very, like, not difficult but very interesting problem. So this is your homework problem. So there are two capacitances, like a parallel plate capacitor where the potential applied is V, and there are two dielectrics which are stacked like this. The bottom one is epsilon 1, the top one is epsilon 2. So you need to find the equivalent capacitance. The thickness is given as D, and the area is equals to A. So do you have do you guys have any lead how we will start this problem? Like, for sure it's not connected in parallel or in series, so we can not directly apply the formula for parallel or series. So how can we do it? Let me give you the solution for this. C equivalent is A epsilon naught epsilon 1 epsilon 2 by D epsilon 1 minus epsilon 2 ln epsilon 1 by epsilon 2. This is the final answer. Anyone can tell me how we will start this problem? Do we need to assume something, or like how can we start? It's not the simple case of parallel or series. Also, there is no no force is applied. Like, it's a simple electrostatic question. Here, like, let me give you some hints so that you guys can proceed. So what you guys need to do is take a very small strip of width or length dx, Assume the total length as L, and this strip is basically at distance x. So this distance will be L minus x. Now this capacitance is basically C1, and this capacitance, not C1, you can call it a very small capacitance, DC1, and this will be very small capacitance, DC2. Now these two capacitances, capacitance DC1 and capacitance DC2, are connected in series. So the DC equivalent, so the equivalent capacitance of this region can be written as 1 by DC1 plus 1 by DC2. Also, you need to assume, so how will you calculate DC1? So for DC1 can be written as epsilon naught A by D. So for that, you need to know the area of this small region. This small region. What should be area of this small region? The area of this small region will be dx times w. Assume w as the in plane width. And what about the height? Like, what about the distance d? So because this strip is so small, you can assume like this is not slanted, but there is this distance d. Or what you can do, you can assume like you can point it like, you can point it like A, B, C, and this value AB can be calculated from the concept of similar triangles, because we know this distance as D, and we also know the distance as L. So what I am saying is this: if we draw there is this small strip, this distance is L, this is D, this is the separation. Now we need to calculate this distance A, B. This can be written as AB by this small distance L minus x, it should be equal to d by this distance L. So AB can be written as L minus x by L times d. Similarly, this distance BC can be written as BC by x, and this height d times L. So BC will be x by L times d. So from the concept of similar triangle, you have AB height L minus x by L times d and BC height x by L times t. Okay, so now DC1 can be written as epsilon naught, uh, area can be written as dx times width by AB. This is DC1 basically, and DC2 can be written as epsilon naught times dx multiplied with w by distance dc. Okay, so the final capacitance dc can be written as dc1 plus dc2. So by solving this, you will get the value of dc. You need to calculate that. After solving it, the capacitance is basically epsilon naught A by D. So you need to calculate the capacitance from 0, this DC 0 to C, and this whatever you are getting from 0 to L, where L is the length. So after solving this integral, finally you will get capacitance value A epsilon naught epsilon 1 epsilon 2 by D epsilon 1 minus epsilon 2 ln epsilon 1 by epsilon 2. So please, this is a very interesting problem. Please give it a try, because you might see some of the similar problems like this. Like what happen if the distance here is given as d1, but this distance is basically a function of x. Basically, case of non-parallel capacitance. Okay, so these are the numericals on capacitances. Now we will move to another module, which is basically calculating equilibrium position of electrostatic actuator under bias. Here, generally what happens, the top plate is connected with some spring and the other plate is basically fixed. So this plate is movable, but this plate is fixed. So the capacitance is basically is a function of distance. Okay. So suppose the resultant equilibrium displacement is x. Okay. So this F electric can be given as half epsilon A by x plus x naught square v square. What is x naught? X naught is the initial displacement or displacement under no bias. Here the mechanical force can be sorry the mechanical force can be written as Fm is equals to minus kx Fm can be written as minus kx. So x is Fm by k. But in equilibrium, Fm is equals to F electric. What is F electric? F electric is half epsilon A by x plus x naught square v square. So minus x is equals to cx v square by 2 x plus x naught km. So you can solve this quadratic equation. So basically there are two forces here. One is Fm, which is basically a mechanical force, and another one is Fe, which is electrical force. So Fm is basically k times x, which is a linear solution, and Fe is basically a quadratic solution. So what we are going to do, if we are if we need to plot force with respect to displacement, the Fm will be like this, and Fe can be right this, because it's the quadratic solution. Now if we increase the voltage, then this curve will have another set of roots. If we again increase it like this, there will be certain roots, and there must be one solution where both the roots are the same one. So what we are doing, we are increasing the potential or voltage. And this case, so the potential where both the roots are equal is known as pull-in voltage. Okay, so what do you mean by pull-in voltage? In pull-in voltage, both the capacitor plates will be pulled to each other, so that these two plates will make a contact. So like they will collapse like this. So the distance x will be 0. So minus x is equals to cx v square by 2 x naught plus x km. Here we will calculate ke. So ke can be calculated as this, which comes out to be 2 km x by x plus x naught. And what we will do, we will put ke is equals to km, so it will be minus 2 km x plus x naught. And after solving ke equal to km, you will get the value of x as minus x naught by 3. So the value so the deflection x, or we can say the minimum value of deflection x, which will make the two plates collapse, is s equals to minus x naught by 3. So using this formula, this one, we can write as v square minus 2 km x plus x naught by c, and put x is equals to minus x naught by 3. So v square will be 4x square by 9c km, and pull-in voltage can be written as 2x naught by 3 under root km by c. Or you can write it as Vp is equals to 2x naught by 3 km by 1.5 times c naught, where c naught is basically no bias capacitance. Like you can calculate c naught as c naught is equals to epsilon a by d, and c, where we can say it like pull-in capacitance is epsilon a by d minus d by 3. So it will, by solving these two equation, you will get c is equals to 3 by 2 c. So this is the concept of pull-in. Now we will solve a question of two parallel beam. So these two beams will support one plate of the capacitor, and another plate of capacitor is fixed. So I think I have a diagram for that in here. So I'm talking about this figure. So the question is, a parallel plate capacitor is suspended by two fixed guided beam. The length is given as 400 micrometer, width is given as 10 micrometer, thickness is given as 1 micrometer, and Young's modulus of this beam is given as 20 gigapascal. The gap x naught is given as 2 micrometer. Area you can consider as 400 micrometer times 400 micrometer. So what you need to do, you need to calculate first, find the force constant. Second, you need to find the pull-in voltage. Third, calculate the amount of displacement x when a voltage of, there are two cases under this third point, zero point 0.4 volt is applied and another is zero point 0.2 volts is applied. So please try this question. So tell me, these beams are what, guided beam, or I've given it fixed? It's fixed guided beam. Okay. So what is the coefficient for fixed guided beam? Can anyone tell? For fixed guided beam. Coefficient is 12 by I by LQ. Okay, so let me explain the diagram. So there are these two beams, one and this two. The coefficient is given as km1 and km2, like you can write it as 1. So we are applying the force in this direction. So there will be bending like this, and this is the top plate, and there is one second plate which is fixed. So only the top plate will bend. So these two beams, beam 2 and beam 1, will experience some force, so that you can calculate the stiffness constant of this beam and this beam. And both of these beams, beam 1 and beam 2, are connected in parallel. So first you need to calculate the coefficient of one of the beams, then calculate its parallel combination value. Please try. I'm coming in 2 minutes. Sorry, guys. So, anyone got the answer? You can unmute and say no one. So, in this question, what you need to do first? First, you need to calculate the coefficients. So, as I said earlier, it's a fixed beam. So, the coefficient will be 2 by I by L cube, and it is coming out to be 0.01875 Newton per meter. Since these two beams are connected in parallel, hence K equivalent will be 2 times K, which is 0.0375 Newton per meter. Okay. Now, what about the pull-in voltage? So, the formula for pull-in voltage is given as 2x naught by 3 times Km by 1.5 C naught. Here, C naught can be calculated as epsilon A by D, which is coming out to be 7.083 into 10 power minus 13 farad. And by putting this value to this, Vp will be 0.25 volts. Now, so we have the force constant and we have the pull-in voltage also. So the third question is calculate the amount of displacement x when a voltage of 0.4 volt is applied. So what will happen? So if force, sorry, if potential of 0.4 volt, which is greater than Vp, which is pull-in voltage. So what do you think? What will happen? Can you calculate the displacement x if you are applying a potential more than pull-in voltage? So for this case, when applied voltage is zero point 0.4 volts, the plates has already in pull-in state, and hence value of x will be 0. Now for the other case, when 0.2 volt is applied. So since voltage is less than Vp, hence we we will see some solution. So there must be a deflection. So how can we do that? So we have the general formula minus 2 kmx x plus x naught by c, or minus 2 kmx x plus x naught squared by epsilon a, So after solving it, we have this cubic equation plus v square epsilon a by 2 km, which is equals to 0. So you need to solve this equation. So we will find three solutions. So I have the three solutions here. The first value is x1 is equals to minus 2.45 10 to the power minus 7 meter. The second solution is minus 1.2 into 10 to the power minus 6 meter. And the third one is minus 2.5 into 10 to the power minus 6 meter. So here we know that uh, the distance between two plates was distance was 1 micrometer. Here, if the distance between two plates was 1 micrometer, then this can't be true because the value is itself greater than that value. Also, this thing, no, I guess the value was not 1 micrometer. Sorry, this is the thickness. Thickness is 1 micrometer. I'm talking about this, the displacement. So the displacement was 2 micrometer, and hence this is the correct solution, as x needs to be less than x naught by 3. What is x naught? X naught is 2 micrometer. So x should be less than 0.66 micrometer. So the only solution possible is this. Okay, next question we have a parallel plate capacitor with area 100 cross 100 micrometer square is supported by 4 cantilever beam. The plate is made of polysilicon that is 2 micrometer thick. Separation of plate is given d is equals to 1 micrometer. Each cantilever beam is 400 micrometer long, 20 micrometer wide, and zero point 0.1 micrometer thick. So the question is, find the relative change of capacitance if acceleration is 1 meter per second square. So here the parallel plate capacitor A. So these are So there is this capacitor which is supported with four beams like this. So please try this question. Please email week 2 numericals on basic electromechanical. Hi, Dr. Shashikala here. Dr. Shashikala, you want these material or other set of questions? Yeah, as soon this class gets over, I will share this material with you. So actually, there is this folder for all the TAs. So not the folder, but a Google sheet where all these three TAs, me, Amay, and Vaishali, will put the link of this Google Drive so that you can access all the material. So I hope you have that link because I don't have all the email IDs of all the student enrolled in this course. I hope you have that link, right? If you not, no, okay. So if you don't have that link, you can mail the NPTEL coordinator or the NPTEL support staff. They will provide you the link. Or what I can do for you four guys available, My email is nalin20 at the rate iserb.ac.in. You guys can mail me at this email ID and I will provide you the link. Is it fine? Yeah, so please note down this link, note down this email ID so that you can mail me. I will provide you the link, and this will be the same link for I have also posted the week 1 material, and the week 3 and week 4 material will be going to I will be going to put in that folder only. So this that will be very useful for you. Okay. So I hope you guys have solved this. Is it in the same folder where we get the week material? Yeah, yeah, yeah. So, have you guys have the link of that folder? You guys can access week 1 material, which I have taught. You have access now. So, in that folder only, I will put this material by today evening. Yeah, sure. Or you can also mail to me or mail to NPTEL support staff. They will help you. Okay. So for this question, should I remove this mail ID? You guys have written now. Okay. So we know that for fixed guided beam, K is equals to 12 by I by L cube. We can also say that these four beams are connected in parallel. So K equivalent is 4K and the value is 0.000187 Newton per meter. The force can be written as Kx and the X is force by K. So for that, we need to calculate the force. Now, how can we calculate the force? The force can be written as mass into acceleration. The acceleration is given as 1 meter per second square, and the mass value. So we don't have the value of mass here, but I think we have the density. Uh, density. Wait. Micrometer. I think I've missed out in density, but anyways, density can be written as mass upon volume. So mass is basically area, density into area into thickness, and mass value is coming out to be 46.6 into 10 to the power minus 12 kg. I will check this one, the value of rho. So I will give it, the mass is coming out to be 46.6 into 10 power minus 12. The force will be 46.6 into 10 power minus 12 Newton. So we will put this value in this formula in equation 1. So the x will be force by k, and it is coming out to be 0.248 micrometer. Here we can calculate capacitance epsilon A by D, which is coming out to be 88.5 into 10 power minus 15 farad, and epsilon A D minus the change. So basically this deflection value x, or we can write it as x only. Mhm. This value is coming out to be 117.7 into 10 power minus 15 farad. So finally, the change in capacitance percentage C is basically C minus C naught by C naught. This is C naught, this is C, and this value is 33%. The answer. So I think the last question for today. So there is this system. So the length of this beam is given as 150 micrometer, and the separation between these is given as 2 micrometer. So there is this two charge, one it is attached with this beam, and one is there at the platform. The charge q1 is given as 8 into 10 power minus 15 coulomb, and this charge q2 is minus 1 into 10 power minus 14 coulomb. For this beam, the width is given as 5 micrometer, and the thickness is given as 2 micrometer. Okay, so the question is, how much would the cantilever beam bend down at its free tip due to electrostatic force? Here you need to assume the beam will not collapse. So this is the assumption you have to make. So we know that for free, like not for fixed guided beam, the free beam, the coefficient is 3yi by L cube, where I is moment of inertia, W2 T cube by 12, as the force is perpendicular to the width. We are applying force in this direction. Not we are not applying, but because of there are two charges which are opposite in charge magnitude. That's why they will try to attract. So there is this transverse force Ft, and moment of inertia will be Wt cube by 12. This Kt is coming out to be 1.5022 Newton per meter. Force, we can write it as Ktx. Now we have this Kt and we need to find the deflection x. So first of all, we need to calculate the force between these two charges. So these two charge, the force, we have the formula 1 by 4 pi epsilon naught q1 q2 by r square. We have the distance, we have these two charts, so very easily we can get the uh, formula, the value for f. But there is this thing, when these two charge, when this beam and this platform, when there is this deflection, so what will happen? So this beam will bend like this, and there will be a deflection x. So the value of force will be force of electrostatic will be q1 q2 by 2 minus x square, where the separation is 2, and now because of the deflection, the distance between these two charges will be 2 minus x. So we will put this in this. So finally it will be the value of charges q1 q2 by 2 minus x square. After solving it, it will be a cubic equation, and after solving this cubic equation, we will have three solutions. X1 is 0.138 micrometer, x2 is 1.4188 micrometer, and x3 is 2.5 micrometer. Here we can easily neglect this value. Why we can neglect it? Because the original separation was 2, and we can't have the deflection more than the value of separation. Also, we have written somewhere that you need to assume the beam will not collapse. The second value, basically we have this condition, x should be less than x naught by 3. So x should be less than 0.66 micrometer, and hence this is also neglected, and the only solution we have here is this. So this will be the final answer. I hope this numerical is clear to you. Okay, so I will share this material. I have 2 or 3 questions more, but I don't think I have time. Uh, so we will see these numericals or the other numericals in the next Saturday, 3 to 5. Yeah, sure.